Today's topic is problem solving using Thevenin's theorem. So let us consider an example. Calculate the current flowing through 3 ohms resistor in the circuit shown below using Thevenin's theorem. This is the circuit given and we need to find out the current flowing through 3 ohms resistor. So when we want to solve the problem using Thevenin's theorem, first step is to remove the load resistance. So what is the load resistance here? As we are asked to find out the current flowing through 3 ohms resistor, here the load resistance is nothing but the 3 ohms resistor. So the first step, remove the load resistance. That is, here we have to remove the 3 ohms resistor. So this is the circuit what we are going to get. After removing the load resistance, the second step is to calculate Thevenin's voltage, that is VTH. VTH has to be calculated across the open terminals. So here the open terminals are these terminals. Therefore here we need to calculate the VTH across these two terminals. So when we want to calculate VTH is in parallel with 16 ohms resistor. Therefore, first find out the current flowing through 16 ohms resistor. Therefore, applying KVL, voltage rise, that is 30, is equal to sum of voltage drops, that is the voltage drop across 10 ohms resistor and the 16 ohms resistor. And it is given as 30 is equal to 10 into I, that is I into R, plus 16 into I, that is 30 is equal to 26 into I. Therefore, I is equal to 1.153 amperes. Once we determine the value of I, we can find out VTH as VTH is equal to the current flowing through the 16 ohms resistor into resistance, that is I into 16, which is equal to 18.46. Step 3, we need to calculate RTH. So in order to calculate RTH, the voltage sources present in the circuit has to be shorted. So in this circuit, we have a voltage source. Therefore, the voltage source has to be shorted and we need to determine the Thevenin's resistance. So when the voltage source is shorted, the resistors 10 ohms and 16 ohms are connected in parallel. So as these two are connected in parallel, the equivalent resistance R is equal to 10 into 16 by 10 plus 16, which is equal to 6.15 ohms. The resultant resistance R will be in series with 8 ohms. Therefore, the total resistance RTH is equal to R plus 8, which is equal to 14.15 ohms. After determining the equivalent resistance and the Thevenin's voltage, we need to draw the Thevenin's equivalent circuit. So the Thevenin's equivalent circuit consists of a voltage source connected in series with a Thevenin's resistance. So here we got the voltage as 18.46 and Thevenin's resistance as 14.15. Therefore, these two has to be connected in series. The resultant has to be connected in series with your load resistance. So here we need to determine the current flowing through 3 ohms. Therefore, the 3 ohms resistor is connected in series with the given circuit. Therefore, the total current IL is equal to VTH by RTH plus RL, which is equal to 1.07 amperes. So this is how we are going to solve the problems using Thevenin's theorem. Thank you.